Hey, yo, geometry friends. How's it going? Mr. Stewart here, talking about translations for lesson 6 of unit 2. So, quick review. Reflection, remember, means that we are going to flip or fold an object about a line. Technically, we could do a point reflection as well, but that ends up looking more like a rotation. So, a reflection flips an object in a plane about a line. Reflection is a flip, rotation is a turn or a spin of an object. So today we're talking about a translation. And a translation is a slide. Just like our slide picture, it can slide to a different spot on the page. It could be horizontal, could be vertical, or it could be some angle in between. It could go over and then up, but it still looks like end result would be a diagonal. So a translation is like a slide of an object. What will happen in our translation is we will measure using the given vector. So this arrow is called a vector. That tells us how far we're going to move our object and in exactly what direction we're going to move our object. So this line segment MV will move in the direction the arrow is pointing, and it'll move the exact distance that the arrow is drawn. So if I were to measure the vector AB, and I can move it to different places, every point in my shape moved in the same direction and the same distance, no matter which point I pick. All these vectors of my translated points will be parallel to each other because everything moves the same distance in the same direction. So a translation shifts all points the same distance in the same direction. The distance and the direction of the shift is called the translation vector. Now, as you get into physics, as you get older and further into high school, you'll talk about vectors as something that has magnitude and direction. So it gives us the same kind of information here in geometry. The magnitude would be the length, and the direction is the arrow that it's pointing. For geometry purposes, the notation for a translation, capital T for translation, and we use a ray to show that it is starting at one point and heading in a specific direction with a particular length. So we use the translation of a ray AB. In order to perform a translation, we have to do a construction that moves every point the same distance in the same direction. But we don't actually have to do the translation of every point. We just do the key points, the vertices, and then connect them when we're done. So if we look at this translation, figure ABCD has been translated or slid over to a new position called A prime, B prime, C prime, D prime. If we draw in our vector, that means we connect any image to a pre-image to image point and show the direction that it moved. What is done for us already is C to C prime as an arrow. Now if I take my straight edge and draw in the vector A to A prime, I need to show the direction that it went, so I have to make it an arrow. And if I do that also with B to B prime, again, point to point, not longer. And I put an arrow tip at the end to show which direction it went. The distance and the direction from each vertex to its corresponding vertex shows the translation vector, and they are all parallel. All vectors of a single given translation are parallel to each other. And if I drag them on top of each other, they line up. Same distance, same direction. Same thing would happen if I did D to D prime. Same distance, same direction. Same distance, same direction. They're all parallel. So draw in the vector that defines each translation below. So grab your straight edge. If you need to pause the video, pause the video. Grab your straight edge. You're going to connect pre-image point to point.
In a few moments, we will be conducting a planned fire drill. When the alarm sounds, please evacuate the building in an orderly manner. Keep your
All right, you can't tell, but I'm back from a fire drill. So we are going to, again, connect the pre-image to the image, and we're going to make sure we line up accurate points, pre-image to image, and show the exact length from pre-image to image, and show the exact direction from pre-image to image by making it an arrow. And we're going to do that with each one of these examples, and you may be faster than me. I don't know, because I'm not where you are. And once we have all three of our vectors drawn, okay, it's not orange, but that's all right. Then we can move on to how to do the actual construction. All right, so to do the actual construction, what we have to do, in theory, what's going to happen is we are going to take this vector and we are going to apply that distance in that direction to each point that's on our shape, so that when we are done, technically, every point shifts or slides the same distance in the same direction, and we end up with a new segment over here. Now, you don't have the same kind of technological advantages that I have with the smartboard, so we are going to do this compass and straight edge style. All right, so here we go. Take your compass. Use your compass to measure the exact length of your vector. So pencil at one end of the arrow, needle tip at the other end of the arrow. We are going to mark this distance from each vertex in the direction of the arrow. So that means if I know my arrow is going straight to the right, I need to mark an arc off to the right. And then same thing up here at point Q. Put my needle on point Q and mark an arc off to the right. That measures the distance that I have to move my point. Next, measure from the beginning of our vector, so the start of the arrow, to the point that we are translating. So notice where my needle is, notice where my pencil is. Do this correctly, please. Measure from the beginning of the arrow to point P. Slide your needle to the other end of the vector, the other end of the arrow, and mark your arc. If you notice, sometimes you may get 2 points of intersection. If I draw this long enough, you can imagine how I would get a second point of intersection. I'll talk about that in a second as far as which one to use. Okay, so now let's do point Q. Bring your needle to the beginning of your arrow, so that's the start of the vector. Measure the distance to the point. Once you have that set, slide your needle to the other end of the vector and mark your arc. X marks the spot where we line up our straight edge. If you ended up with 2 points of intersection with your arcs, you have to use common sense to figure out which one to use to connect to the other end. Remember that our translated figure should be parallel to the original image. If you use the wrong point of intersection, it'll just look not parallel. It'll look off. So choose wisely, use common sense. If I used a point somewhere up here, that would not look parallel to the original. So that means I would not do that. I would not use that point. Use the one that makes sense in the direction of the arrow. And there's our translated figure. So turn the page, try it again. Take our compass, match the setting for the vector. Then you're going to mark that distance from each vertex. In the direction of the arrow. So that means I want my marking somewhere over on this side. From each vertex. Then I measure from the start of the vertex. So in this particular case, that's point A. Measure from the beginning of the vector. Okay, so you're going to measure from the beginning of the vector to the point you are translating. So the start of the arrow to the point of the triangle. Slide the needle down to the other end of your vector, and then mark your arc. So you get a nice, neat X. And X marks the spot where your translated point now ends up. Needle goes back to point A, the start of the arrow, and then we measure to the next point. Next vertex I'll do is F. So I measure A to F, slide my needle down to the other end of the vector. X marks the spot. Back to needle at point A. I'm going to measure to vertex E. And I'm going to slide that needle down to the other end of my vector. X marks the spot. Now I can take my straight edge and connect them. Then I have my translated triangle. All sides should be parallel, same size. Everything moves the same distance in the same direction. So over here is D prime. This is F prime over here. And E prime over there. One more time. This time we only have to do 2 out of the 3 points because the vector uses point K as one of the endpoints of the vector. So I already know where K prime is. So I measure the vector, go to point R, mark the direction where the vector will go to point O, mark the direction where the vector will go. And I already know that K prime is the tip of the vector. That I already know. So for my construction purposes, I'm going to measure from K, the beginning of my vector, to point O, and then I will mark the distance, measure from one end of the vector, mark it from the other end of the vector, and then I can figure out where O prime will be. Now I do R. Measure from the beginning of the vector, slide the needle down to the other end, mark it from the other end of the vector. X marks the spot where I'm supposed to line up my straight edge. Now, hopefully you're getting a more accurate result than I am. That's the beauty of trying to do this on technology. Because of the pixels, it doesn't always land exactly right. But those are the steps. That's how you do it under 15 minutes. Now you go practice. Good luck, stay safe, and I'll talk to you soon.